Hello everyone, my name is Yuwen Peng. Here I want to show you with my master thesis, the line planning incorporating truck routing in intermodal transit networks towards the integrated passenger and freight mobility. First, I want to start from my motivation. With the continuous growth of the economy, urban freight demand is increasingly rapidly. Yet in most big cities, the road network is already at or beyond capacity. The result are same: the congestion, the higher cost, and the emissions. Now, also the urban rail transit offers a complementary resource. It has fixed roads, stable schedules, and importantly, the high and underutilized capacity. That makes the URT to be a great way for freight. And now it's need to the passenger freight co-modal mobility, which means that the passenger and the freight sharing parts of the same infrastructure or capacity and clear routes. Several practices in places like the Netherlands and China already show it can work when operations and transfers are well designed. However, integrating the freight into passenger system is not easy, so the questions become to a strategic one. Which lines should operate at what frequencies for passenger and for freight, and what should the intermodal facilities be built? So our thesis will ask that how line planning in intermodal transit networks being optimized to integrate the passenger and freight mobility for efficient transport coordination. And then after reviewing the literature, we found that the line planning problem for the single modal network has been well explored, but mainly within the context of the passenger mobility. And also, most existing studies on the integration of passenger and freight, they just focus on tactical or operational level decisions, such as timetabling on a single line, and carriage allocation, or rolling stock scheduling. And also, the strategic level planning and the network level resource optimization have received limited attention. Our contribution are: first, we propose a new integrated optimization framework for capacity line planning with truck routing in an intermodal transit networks. And the core objective is to coordinate the resource allocation across metro and truck services at a strategic level. And also, we formulate a path-based model to optimize the line plan and the truck routing and also the freight transfers and the routing decisions. And last, we propose a column generation algorithm with a level 2-stage diving procedure. And in this thesis, we consider an intermodal network comprising the URT and road-based truck services to serve both the passenger and the freight demand. We built two complementary abstractions: the two-layer PTN to describe the physical infrastructure, and the two-layer CHN to capture the feasible passenger freight movements and transfers on the infrastructure. And the left is the PTN. It captures the physical conductivity only, and the right is the CHN. It can also capture the transfers between different travel modes or the same travel modes. Here we consider both passenger and freight origin destination demand here. Let P denote the set of passenger OD pairs, and H denote the set of freight OD pairs. And we assume that the passengers are served only by URT services, where freight can be transported via truck services, URT services, or a combination of both services. And in this network, as you can see, for freight, it has two routes. The first one is use the single modal, use truck line 1, and the second one is in the intermodal, use truck line 2 to reach the station B, then transfer via the freight transfer facilities from truck to the URT, then take URT line 1 to station C, then transfer to URT line 2, then arrive station D. And for passenger, it can only use URT system. So for the single modal, it can use the URT line 2 to directly arrive at station D, or use the URT line 1, then transfer at C to URT line 2, then take the line 2 to station D. Then to validate the proposed model and algorithm, we designed an experiment based on a grid network as shown in this figure. And the network consists of 25 real nodes, each supporting two modes of transportation, the metro and the truck. So we have a total of 50 mode-specific nodes here. Then we made many experiments on the grid network. Let's see the result. As you can see, our algorithm achieves an average of more than 95% reduction in the computational time, and where the finding solutions with an average optimality gap of only 0.77%. We also made an additional experiment to show the impact of incorporating truck routing. As you can see, when the budget becomes more constrained, using only the metro system often fails to meet world demand. And in construct, the line planning approach with integrated truck routing maintains feasibility by flexibly reallocating the resource across the two different modes, achieving the enhanced service quality through better coordination rather than additional investment. And to evaluate the practical effectiveness of the proposed model and our solution approach in real-world settings, we conduct a real-life case study on the Rotterdam URT network. As you can see, we first, based on the real line and the frequency, calculate the B base as our baseline budget. Then we make three different experiments based on three different strategies. The first strategy is that we fix the existing URT line plan and preserve the observed frequencies for each line. The optimization only determines the frequency allocation between passenger and freight flows on each existing line. And the second one is that we fix the 5 currently operated URT lines as part of the network in the first stage of our two-stage diving heuristic, after which we continue the active-only dive over the remaining candidate lines. And the second one is that we make a complete optimization without prefixed lines. As you can see, the stage 2 and the stage 3 both have a reduction based on the stage 1. So we can know that when new operational requirements arise, such as shifting from passenger only to integrated passenger and freight services, the most effective solution and a fixed budget is to redesign the intermodal line plan from scratch. The full optimization achieves the greatest service improvements. When such redesign is not feasible, expanding around the current URT backbone still yields meaningful gains. We are maintaining the existing network with only frequency adjustments also offers limited benefit. Okay, that's all that I want to share with you about my master thesis. Thank you.